All right, so we're talking about average value of a function in today's class. So this is AP Calculus. For us here, it's Calculus 30L class as well. So the average value of a function. Now, what I want to talk to you about is average is, you know what average is, right? Average would be the mean value, okay, or the mean. So you take all of the points and you add them all up, divide by the number of points that you've added, and you get sort of an average. So that concept is important here. Value of a function, we need to understand that this is the f of x, or the y values. Okay, so it's the average y values of a function over an interval. Okay, so it's over an interval. Now, I just want to take you over here to this graph on decimals. I have two graphs shown here. Okay, so the two graphs that I have shown are y equals 2x cubed, and that's the portion of this from 0 on here is the red graph. Okay, if we zoom out, zoom out a little bit, you can see that it's a cubic function. Okay, and the second one over here is y equals 2x, and these are the tables of values that we're going to use for this. So I've got the points on the graph. We'll zoom back in here. And I want to compare these just to try and explain to you average value. So if we're talking about a straight line function, okay, over the interval of 0 to 1. Let's talk about this function over the interval of 0 to 1. If I take a look at values of x, okay, every 0.25 units, I'm going to take a measure of the value of the function. And I do that between 0 and 1. These are including zeros, these are the 5 points that I would get. 0, 0, all right, 0.25 and 0.5, and 0.5 and 1, 0.75, 1.5, and 1, 2. You see that? Now, what's the average value of these values? What's the average? How would we find the average? Well, we would add up all the y values here, and then we would divide by 5, and we would get the average value of this function. Okay. Now, if you took twice as many points, you would just add up twice as many things, divide it by twice as many items, and then you would get the average. Now, with a straight line, it's pretty easy to see that what is the average here? Can anyone guess what the average is going to be? 0.5? Okay, so 0.5 or 0.25, which one are we talking about? This one? This one. Okay, so this point right here, you think that would be the average. Well, if everything is rising at a constant slope, right, each of the points that we consider, add them all up, this looks to be the average. The average value of this function would be y equals 1, but it's at x equals 0.5. Okay? Right. Got it? It's average of 1. Now, let's just prove that. Okay, so if we look at these points on the blue graph, we are going to look at the y values right here, and because we've taken a 0.25 value and we've done this repetitively with equal space in between, I'm going to take the values of these y values, I'm going to add them up, I'm going to find an average value for the function. So we started that over here in the notes, right? So just copied that chart. If you add up all of these y values that are taken at regular intervals within that interval, we find that the average value is 1. Now that's the y value that we have here. Y value is 1. Okay, so that's great. Now the focus here is on the red graph, on the y equals 2x cubed. Now these numbers are a little bit different, aren't they? These numbers are still taken every 0.25 units, but I want you to notice something, that the y values that we're going to add generally are quite a bit lower. You see, because this graph basically hangs out down low for most of the interval and then sharply jumps up to meet at y equals 2. So if we take a look at these values that are taken at, again, equal intervals, and we add up these y values to get an average, divide by 5, this is what we're going to end up with. So here's the working of the second graph, where we have all of this divided by 5. So what do we get when we add all this up? Sorry? No, I don't think it's quite 3. Let's just add that up real quick here. So 0 plus 0.03125 plus 0.25 plus 0.84375 plus 2. 3.125 divided by 5 is 0.625. Okay? So 0.625 is our average of all of these values. This is the average, 0.625. Now what that indicates to us is that seems like this is the average of all of the y values on the function if we take at regular intervals. So again, if we double the intervals, like double the number of points at regular intervals, then we'll have more points, but we'll be dividing by more values, and we'll find that we get the same average. So here's the average value for this function, but the average value here is somewhere down around here. So 0.6, where is it? 0.625. So we're coming down, you see that right there. That is the average value for this, the average y value for this function. Sorry. I'm sorry. I'm looking at the wrong one. 0.6, it's up here. 0.625. Yeah, right here. 0.625. The average value is here. Okay? So, do you have to do this table of values? No, you don't. There is an easier way, but what I'm trying to communicate is sort of the concept of what the average value of the function is. What's another way to look at this? Okay. Another way to look at this, if we just take a look at this graph right here, and again, I'm going to sort of, I'm just going to clip this graph out and bring it into my notes so I can show you this. All right. So the average value of a function. So if we were talking about an average height, okay, an average height, think about this way. Think about it this way. What does this represent that I am filling in for you here? What is this right here?
Right triangle.
Okay, it's a right triangle. We're talking about an area, talking about an integral. Okay, all these are very good. All right. So the average value of a function, okay, so if we're thinking about area, right, the average value which we know to be right here for this line, okay, think about the area as length. So this would be 1 minus 0, right, the length. And then for this triangle, okay, this would be the height, would be 2 units high. This average right here would be the average value that would make a rectangle of equal area. Okay? So if you think about area, this average value function would represent the height right here, average value, that would make an area of a rectangle that would have the same amount of area as the area underneath the curve. Average value. So length times height, if we're talking about value of an area, right? Length times height. Now, let's take a look at the second graph. So I'll light this one up, take this one away. Well, let's clip this into our notes. And how does average value of a function relate to area under this curve? Okay, so about 0.625, let's say is this 0.75, so somewhere around here. This is our average value, and here, okay, so here is our area underneath the curve, quite a bit less than the other one, isn't it? Now think about this. This value right here, approximately, would be the average height, or the height, of the rectangle that has the same area, given the same width. So if this is 1 minus 0, right, from here to here, and this is our height, we're not talking about a triangle anymore, but if we use this average value of a function, this would give us the rectangle that has an equal area. Okay, So, think about that. Area, all right, which we've got, area is length, right, which is, okay, we'll just say length, and then times height of a rectangle, okay? So if we are actually looking for an average value, then we're actually looking for the height, okay? So height here is actually equal to the area over the length. Everyone see that? If we're talking about a rectangle, this is pretty straightforward. But what if we're talking about the area underneath some random curve? Then how can we represent that area? It was mentioned here before. The height would then equal the integral, and I'm going to, integral of the function. And it would actually be between sort of, well, I guess A and B, whatever that would be, right? But that is that's the length, okay? So divided by, we'll go B minus A. So if the height is what we were calling now the average value, because that's the equality that we've established. So this is the average value of a function average, and I'm not sure exactly what. I think that's sort of the notation you might see in your textbook. Really is 1 over b minus a times the integral of f of x dx given from a to b. And it comes from the fact that the area under the curve and length and width of the equivalent rectangle with the equivalent area. Okay? So this is average value of a function. And we can see that this average value height, if the area is less, the height is going to be a little bit less. So let me just sketch another example for you. This one isn't going to be quite as neat. But let's say we had something like this. Okay. What's the average value of this function? Do you think it would be greater or less than halfway between 0 and this maximum value here? Okay, probably greater, right? Because if we're considering area, right, the equivalent rectangle would probably have, I mean, this wouldn't be the same if we went halfway, right? That's not the same. So it's not that one. It's definitely not 0.625 like the other one. That's, this area is way too small. So it's going to be somewhere probably up closer to this value maybe, right? And so this would be what we're looking for. So how do we find that? Well, we find the integral from a to b of whatever function this is, f of x, dx. And then we're going to divide it by the sort of the width to find the average height. Okay? So it's going to be times 1 over b minus a. And that's going to be your function average. Again, the same thing that we have up here. Okay? So how does that sound? Any questions?